interested to describe something that looks like this. We can compute standard deviation. Yeah? If this is the distribution of your data, measurements, some emission line profile of an astronomical radio measurements, yeah? Then you can compute the standard deviation, which is defined. It contains 60-something% of all the data, so the area is 60-something%. Yes, so that's maybe here. This is the standard deviation. This gives you a number to describe how wide your thing is, but it doesn't. I can come up with with data that has the same standard distribution but looks completely different. Let's say we have something like this. This might have the same standard deviation, but has a different shape. Is much more peaked. Has much fewer wings or less extended wings.
Then the skewness is lower.
The skewness is higher. I think the skewness.
If it's symmetric, the skewness is the same. But
No, the kurtosis.
The kurtosis is high.
No, let's say kurtosis ist
in the old one.
Der Abstand zum Erwartungswert um 4. Das bedeutet, die nah am Erwartungswert sind, die tragen wenig bei, also fast gar nicht. Und die weit weg sind, tragen mehr bei.
Genau. Yeah. So this would be visible in the kurtosis. We can also the standard deviation also doesn't tell us whether it looks maybe if it has a wing on one hand side. For astronomy, that's extremely important because usually this is an indication of turbulence or outflows. So because it prefers certain Doppler velocities only on one hand side of the mean value. So it's a physical effect.
Maybe I should be more precise. I can see those effects, right? I can just plot the thing and I see this, and now I label it a nice little number. And what to do with the number?
Well, the number, you can compare it to other.
It's a quantitative measure of what you see by eye. So if I have 50 of these measurements, I cannot plot them all in one single plot. It doesn't make any sense. It doesn't because it just you can't see anything. But maybe you would like to have a statistics on how prominent are the wings, and it's one way to quantify this. You can come up with others.
Yes, this always shows you how far the most likely occurrence is away from the mean value. Because if there's no skewness, your mean value is automatically the most likely items. Event, right. But if there's a higher skewness, that means that the mean value it shifts to the right. It's not where the peak is, the mean value. It's not the most likely.
Okay. Interesting.
Yeah?
Yeah,
okay.
I think I got the idea. I just never made any calculation where there was something like take the fourth moment and use it in a function or something.
Okay.
Yeah.
Okay, good.